Yo, yo, what's up, what's up? Today we're working on my Rust OS written for fun, um, with the intent maybe long term of like running a web server or something. I kind of want to like build up the fundamentals of an OS, try to figure out how it all works so that I can build a better intuition about how my own software runs on normal computers. So where we are today is last stream we implemented a bunch of like interrupt handling stuff. And if I look at this, I there doesn't really do much right now, but I added some like printing and debugging, and even as like a prereq to this, I added like a bunch of printing and debugging for this like global descriptor table. And I don't really want this here, but I also don't want it to be gone. So here I have these like prints, and if I like take them out, like this, I think, I go run build, I get like a bunch of like, hey, you have all of these things in your code base and they're not used. Like, why the hell did you make these? Get rid of them. They're dead code. And I kind of want them around for if I want to debug stuff later. So I could just like mark them as unused, but also I probably don't want to re-implement these print functions later either, and I don't want to have to like know where they are. Would be kind of nice as if I had some way to like track down, like I'm like, oh, there's a bug in this area, let's look at the logs and see what's going on. And so that's what I want to look at today. Is right now we kind of only have printf debugging and or sorry, I should call it print line debugging because we're in Rust. But I only really have printf debugging and GDB through QEMU. And what I want is some sort of like logging system. So that's the goal for today, is like implementing a logging system for my kernel. So one challenge here, there's a couple of things that we need to like keep in mind while we're implementing this. One is that we need some way to like toggle on and off different modules or log lines, etc. So let's find like I think other Rust logging infrastructures have these like module based enable disable flags, and so I could probably look at that. Maybe we could go like really down the rabbit hole and look at line by line enable like you can do in the Linux kernel, which might be useful in some way. So we'll keep that in mind. Another thing that we want to do is we might want to like handle logs from interrupts correctly. So right now, our interrupts will just try to get like a mutable reference to some printer, and in that, how do I say this? If I'm interrupting while someone's logging, then I'll just get like a double reference and my program will crash or my kernel will crash, which is really bad. If my logger comes up after some parts of the system, I might want to like buffer those and print them when the logger comes up. Again, the Linux kernel, I think it does the same thing, where you get a bunch of like early boot messages, but you get like 7 seconds of logs at once when the IO system comes up, which is kind of nice. And a trick there, like something there might be kind of tricky because our logger will come up. Maybe our allocator will push logs to the logger before it's come up, which means that we need to support maybe working in like a no allocation mode. Yeah, okay, and then we might want to do some like colors and stuff, like green debug messages, blue info logs, red errors and stuff, just to like, wow, pretty. Yeah, so that's what we're gonna look at today. I think we'll just start moving. So I'm working. Yesterday we were working on interrupts, and since I don't want to like complete that before the logger is done, I've just kind of jumped back one commit into like GDT is up and running, but the interrupt table isn't. Okay, so I guess we'll make a new module called logger, and in main, oops, I already have this open. So I just have to do like this. Here we go. So let's look at source logger. And in main, I have to include this logger for it to be built. So we'll just do mod logger. And this probably has to go towards the top because we know we're going to be defining some like logging macros in here. And we can probably also assume that they're going to be printing. So maybe we'll go print, logger, everything else. And for now, let's just kind of return early in here. And shut down early. And then let's just do some tests. So we'll do logger init. Probably this isn't how this is going to look forever, but I just kind of want some like an area to start typing stuff. Cool. And now let's try to figure out how we want to make our logging structure look like. So I know that I've seen like people do rust env or rust log equals like kernel logger debug or something like this in before you launch your command. And then I've seen logging creates switch behavior based off this kind of thing. So what I want to know is where does this string come from? And so let's just kind of start browsing some docs. So do I have a window open yet? Yeah, here. We'll just look at, I don't know, module path, module name. We'll look that up in Rust. Module. Okay, so they have a module path macro that expands to a string that represents the current module path. Okay. So then we can come back here and let's just see like what this looks like. So print line module path, I think it was called. And just see what this looks like, and then we'll use core module path. How? Oh, I'm just learning now about this macro export button. Okay, so let's just show this in here. Macro export. Macro export on other modules. Okay. So let's just see what this prints. Kernel loggers, that is what I wanted. So I think that is basically the answer to this. We'll use module path. And we'll call that done. That's pretty easy. So we'll just use the module path to define logger. And then I guess maybe this isn't quite complete because we'll also need a way to set up, like initialize this. And maybe we'll want to like set defaults in each module, probably. And the question is, where should those defaults live? Like probably inside the module themselves. So probably what we'll want to do is we'll want to like use logger. Oh, we're already in logger. And maybe we'll want to do like, we'll probably want a function like pub function set log level. But it would be kind of nice if we like bake it in at compile time, so we don't have like every module running like static initialization code like you would in C++. I wonder if there's a way to go from like module path. I want to like find a way to automatically inject this into the logger. So, okay, we could maybe get a little crazy here, and maybe we want to save that for later. But I've seen in other, there's ways to like inject compile time lists with like the linker and use that to like have like something iterable at runtime, and then in my init you could like iterate over this array injected by the linker filled in with things from each module and use that to initialize logger. I don't want to go there right now, so I'm not going to do that. But that's my first idea of how to implement something like that. But let's ignore for now. For now, let's just say that on initialization, you can pass in like log levels, and these will be initialized from main. And we'll just make a struct log levels that has like a hash map. So use hash brown hash map of we'll call this levels. I guess we don't even need this to be its own struct. We can just make this be a hash map of like strings to level. And so we need to define our like level struct. And we'll have like debug. This isn't a struct, right? This is an enum. Public enum. It has debug info, warning, and error. Right? Okay. That seems reasonable. So here we get a series of log levels, and we'll just print these out. We'll take this back out so we can compile it. Yeah, I was considering using envars at compile time, but I don't like the idea of recompiling when my environment changes. I'd rather have something like in the code itself, like some config somewhere that's like baked in or something. That's probably another option, actually, is some resource file that just gets baked in and I iterate that. That's probably more reasonable. Although, I guess in that case, you wouldn't be able to, if you like move a file, I don't like the idea of file moving resulting in like a log level changing, but I guess that's maybe like just a downside of this approach. Anyways, we'll consider all of that later. For now, where was I? Let's just print out the log levels and see what we get. We don't have strings yet, so we can use core or alloc string probably, yep. And I guess I should think about, do I want these to be strings, or am I going to assume for now that this is going to be fully initialized at compile time? And if it's completely initialized at compile time, maybe using a hash map here is overkill. I could just pass in like a what is this called? Slice of string to log level like this. Arguably. Maybe that's okay. We could also get like really rusty and we could say like I is an iterator with item equals stir log level, and then the caller can choose. But that's getting crazy. Probably not necessary, but maybe fun. I guess this gives me the flexibility to choose later. Anyways, whatever. Let's not get crazy here. Let's just go back to hash map string log level, because we do know that we eventually will need storage in our logger, right? If we have like this log manager and we have like the levels of each item, we will have like hash map of string to log level, unless we can put in static stir. Which if we want to enable runtime debugging, we won't be able to. So we'll just do this. That's fine. I'm happy with that. Let's say for now that the log manager doesn't know that it's going to be in static memory, even if it ends up being there. So we'll just make a new function that takes this in and returns itself. And then we return a log manager with levels call this initial levels. In here, we will pass in levels is initial levels. And we'll take this in not by reference so that it can own it, and we'll just throw this guy like this, and we'll make this function public. Which means that here we can create a new logger, which is a new log manager. I guess we can just call this logger. Calling it a manager seems like crazy. We don't know that it's going to be managing anything. Logger, like that, spelled wrong. And now we need to provide levels, so we'll just make this default. And logger is a private struct, so to fix that, like this. Okay, and now let's try. I guess we're gonna have to make like a function to execute a log. And my first instinct here is to put a function in like pub function log that takes in a string to log, and like its module or something, and something like this. But the reason to not do it this way is you actually want the logging to, whether or not to log, should be owned externally to the logger. Because then you can like add arguments that will be conditionally compiled. Like if you had if debug log something, this is different than if you did log something in debug, because you want this stuff to like not run if the log level is too low. So I guess the first thing we need is like a get level for module. And the module comes in as a stir, and we return this as log level. Which just returns this. I guess should be this will always return a level because we always need something, and we'll just make our default level something. So maybe for now we'll just say warning is our default level. Anything under warning gets squashed unless we explicitly enable it. So let's do that. We'll say levels get this should take self by reference, and we'll say self get level. Nope. Levels get, we'll pass in module, and we'll unwrap, or we'll return log level warning. Perfect. It doesn't like that because this guy doesn't implement copy, or we'll have to implement clone as well. So the reason it's getting mad is because this get function returns a reference, and this guy wants a non-reference. I guess I could just return a reference here, probably for now. Although this is, yeah, that's probably fine, right? This is going to be tied to the lifetime of the logger, but presumably these are going to be pretty ephemeral calls, so we can probably get away with that for now. And then we'll want a like log macro, and I just learned that you can write this like export macro or something above and call macro rules. We'll call it log. Built-in attribute with a similar name exists. Okay, so where did I read that export macro thing? Export macro Rust. Macro export, not export macro. Of course, of course. So let's try this again. So this is macro export. And then here we take in a log string, presumably. So, which I think is probably of type expression. Then we would take in the arguments, but the arguments are optional, which I think means that you do like some sort of like weird bracket expansion like this, where you say like, this is the stuff that I want to happen for each argument. So I put a comma in and then I put in more expressions. I think. We'll see. I'm sure this will complain to me because I'm sure that the syntax isn't right. I'm just kind of guessing. And then do we also take in something else? We also take in a level. So I guess the level has to be the first thing because of the variadic arguments at the end. Unless I wanted to take it out. I think it's... You could probably handle it. No. Yeah, you could by like splitting the macro up. But I don't want to do that. So we'll just put the level at the front. So this is called level. And this is also an expression, probably. And then for now, we'll say if logger, well, we don't have a static logger yet, so we'll have to put one somewhere. Let's think about this. For now, we'll just print line s, and then is there a way for me to like expand the args? Let's look up the rules again. Again, like I've ever looked them up before. Macro rules variadic. Rust, of course. Here we go, variadics. Okay. What is this eval? What does that mean? Syntax. Let's... Eval? Oopsies. I've never seen that before. Oh, because they just want to write the token eval in there. Okay. So here they pass in... right, you need to specify that like a name for this variadic, which I haven't done now. So I want this as like args. And then did this guy, he put the comma after, which is odd to me. I would think that oh, because they have a rule for the last one individually, but I'm not going to do that. So I think that this will work. But we'll see. It does not like this, but we'll see. Print line. And then this is, I think I just write args star like this. And then let's see if I say in the new function, we'll just try calling this macro to see that works. So we'll say log level debug. And then we'll pass in test 1. And then we'll return the logger. I guess we'll just do this above. Okay, cargo run. So this macro is working as expected. And so now in here, we just need to find a way to attach ourselves to the static logger. Right, unless we want to pass in a logger reference every time we use one of these. We can instead just stick a logger in static space and then, which is kind of icky, but I think the loggers kind of deserve it. So here we'll say static logger is of type logger. And he is going to, let's think about this, equal logger new. Oh, which actually means that here our initial levels will be wrong. Oh, what I was thinking related to buffering of logs before the manager comes up, you could do something like, instead of putting the logger in static space, you could have like a channel that sends things to the logger in static space, and you could just push messages to there, and then the logger won't service it for a while. You could have like a channel that has like a buffer of n bytes, and when it comes up, it'll just rip through it. So let's see if the Rust core library, how to say this, Rust, I'm looking for channel in the Rust core library, and I want to see if any of these guys are available. So no, this is like pretty async code that doesn't exist yet. But that's actually okay, because it's not hard to implement this myself. So let's start this. This is gonna turn into a little bit of a rabbit hole of implementing synchronized circular buffer. So the idea here is, since one of my goals is to be able to log from within an interrupt, I need to have some sort of like synchronized way of pushing messages to the logger. We don't have any concept of like mutexes yet in our OS. So what we could probably do is, using atomic indexes, which we have now, we could build a buffer that you could push logs into. So if we have like an array of logs, blomp, 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 you could have like an atomic pointer that points to here, head, an atomic pointer that points to here, tail. And you could basically say that like anything in this section is allowed to be edited. I was going to say that you could edit this and then move the pointer, but that's not really true. You could have each of these guys also point out in some atomic way. I'll have to think about this some more. But the idea is that like we'll basically push messages into here and move the head back over and over again from our log macro, and then we'll have some like service function running in a loop, maybe, that handles like actually writing these to the screen. And that fixes a couple things. One, it makes like our interrupts faster if we want to log from them, because it means that we don't have to like wait for IO to the console and IO to the VGA buffer. And it means that like we can log in like hot paths a little better. I think that this is just like better in general. So let's do that. So let's find a way to implement that right now. So we'll go into, let's pause this for a second and make sure that it's compilable. Cool. And let's go into our utility class and make a new module called like atomic circular buffer or something. And what would be especially cool is if we'd get away without allocating anything here, which I think we can. So we'll call this actually atomic circular array, and then we'll source util atomic circular array. And let's just kind of see where this falls over. I haven't really thought this through all the way, obviously. So let's just take a quick gander. So we'll probably have like circular array of item t. And in here we'll have mutable pointers to the t. So we'll have like head. No, sorry. We'll have a slice of not a slice. We'll have an array. And this will be of t. an n, right? So I assume you can pass in n as a number instead of a type. It's actually already mad about that. N is not a value. So how do I pass in, like, does Rust have the concept of like compile time ints? Rust generic int as parameter or something? Numeric values is generics in Rust. Const generics, which have yet to land in stable Rust, but this is maybe from a long time ago, 2019. Oops, I clicked on the wrong thing. Const generics. Or maybe I just const generics. Here we go. Const and usize. There we go. That's what I'm looking for. Okay. So now I have an array that's got elements of size n, and we'll have like a head is a usize and a tail is also usize. And then we'll have to implement some functions for this. So let's just get that out of the way. And this is going to be an implementation that takes in a t and an n. And then I pass those in here. I think this is the Rust syntax way of doing this, but it looks like it likes. We'll add a way to construct this. So I guess initially our head will equal our tail because every element is open. No. Yeah, sure. So at the beginning, we have no elements in here. So our array will just be maybe uninit, I guess. Sorry, I should finish my thoughts out loud. So I'm just realizing now that if I have this array of elements, if I'm going to add like push and pop operations to this array, then actually the majority of these elements will start uninitialized. And so you need Rust's way to like flag that. So you say use core, maybe, what's it called? Maybe uninit. Maybe uninit t, like this. And this will hopefully tell me where this is. Fine, I'll look it up in the docs. Maybe uninit. Core mem. So I'll use core mem, maybe uninit. And this will let me flag to the compiler that I'm going to use things that might not be initialized. So then my array will be fully uninitialized values. For n elements. Our head will be 0 and our tail will also be 0 because that's our way to flag that the array is empty. We'll pass this in like this. T needs marker copy for maybe uninit. Why? Why? Let's see. Maybe uninit t blah 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 is a way to deal with uninitialized data. Out pointers. Initialize an array element by element. Yeah, okay. Unsafe, maybe uninit assume initialized. So this is somehow legal. I'm actually surprised that because this isn't. Yeah, I'm surprised it's illegal. Oh, I see. So then they shove these in here, and then they transmit it back. That makes sense. So why does maybe uninit require copy? Like vectors aren't copy, right? Am I high? Maybe uninit vec u32. So why is it saying that I need marker copy? required for maybe an init t. The copy trait is required because this value will be copied for each element of the array. Oh, I see. So what was this uninit array thing I saw? That's actually what I want. Nice. So that explains why this exists. So this is maybe an init array. Uninit array. Sorry, I misspelled that. Use of unstable feature. No. The example below would let me use this. In future Rust version, this may because inline const expressions. I see. So they're saying like we're marking this as unstable because we don't know if we're actually going to need it. But you know what? I'm down since we're in nightly anyway to just enable this. Because I think I need it. Maybe uninit array. And if we lose this later, then that's fine. I'll figure something out then. Okay, so now we can construct one of these. And I guess we'll just make a push function that takes in self and a t. And he inserts that. Right. So, okay, here's where we start to get tricky, is where I was thinking initially that I wanted this to be usable from a, like, multiple contexts at once. So, I think it's illegal for me to convert a reference to a mutable pointer. And I need a mutable reference to the stuff inside here. And I guess you could argue that pushing two elements at once to the array is going to cause problems. But what we could do instead of all of this is we could use an atomic pointer to t. And then you might say, but then, like, where will it live? And we could leak memory here using an allocator. But then we're back to the problem where this doesn't work anymore with the allocator disabled. So let's think about if there's some way to gain like some form of thread safety here. We could implement a spin lock. Is that crazy? We're going down the rabbit hole. Implement spin lock. Because if we have a spin lock, then we can push things into this array safely. Which maybe, sure. Okay, we're getting crazy here. So source util spinlock rs. And here we pubmod spinlock. And maybe we'll say that we're doing this here. Like this. And we'll say we are here. Okay. File not found for module spin lock, so we'll write it. And let's start implementing a spin lock. So the item underneath is a T that we expect to be initialized, that we want to access through the lock. So we'll just call it inner. We'll make this public. And we need to make an implementation for it. So for any T, we want to spin lock T. And there's going to be a lock function. And this will take in self by non-mutable reference. And presumably it will return some sort of like spin lock guard with a lifetime and t, I guess. Because we need some way to like automatically lock and unlock the mutex, or the spin lock we should call it. Presumably this spin lock guard will have t taken by reference. So we'll have inner is a t with lifetime of a. And presumably we also need a reference to the whatever we're using to track. So when I've briefly Googled this in the past, I've come across the concept of like semaphores. And the idea is that like you have this way to atomically increment and decrement this thing. And if the thing is 0, you're like, oh, we're unlocked. But if it's anything greater than 0, you go like, we're unlocked. Or maybe it's vice versa. If it's 0, it's locked. And if it's anything greater than 0, it's unlocked. Let's quickly Google. Or I guess maybe it's in the man pages. Man semaphore. Man 2 sem lock. Man sem wait. Here we go. Sem wait decrements the lock. If the semaphore's value is greater than 0, then the decrement proceeds, and the function returns immediately. If the semaphore currently has a value of 0, then the call blocks until either it becomes possible to perform the decrement, or a signal handler interrupts the call. So that's what we're going to do here, except we're just going to spin on an atomic int. So we're going to say... I also have no idea like how fucked this is for performance, by the way. I've never really thought about this before. I'm just kind of just bumbling along, seeing how it works. So let's do that. So we have a lock count. Or sorry, we'll say, yeah, available is an atomic bool, I guess. Because I think we should only have this in the state where it's 0 or 1. Let's just double check that. Sem wait. Decrements the semaphore pointed to by sem. If the semaphore is valued greater than 0, I guess it doesn't really matter. We can use whatever convention we want. So we'll just say this is going to be available if this bool is true, and it will be locked if it's false. And in the same way that we take in the inner by reference here, we'll also need to take a reference to available, which is our atomic bool. We need to use core sync atomic bool. And here we'll just need to add a way to like wait for true. So we'll call this wait for true, and we'll take in an atomic bool by reference. I guess we should not do this, actually. I was going to say wait for true, but really you need to make sure that when you increment this, that you're atomically incrementing it. So there's probably self.available, compare, and swap, I think is the atomic way to do this. Let's just pull up the docs here. So we have load and store isn't what we want. We want compare and swap, which is deprecated. Use compare exchange. Okay, so we want to store value into the bool if the current value is the same as the current value. What a confusing sentence. If the current value is the current value, then store the bool. And it's like, well, current would always be cool, current, but it's not, because we want to make sure that current is passed in new. So we want to compare exchange, and the current value, we need it to be false, or we need it to be true. And We want to set it to be false. And now we just need to be very careful with the ordering. So compare exchange takes in two ordering arguments to describe the memory ordering of the operation. Success describes the required ordering for the read, modify, write operation that takes place in comparison with current succeeds. Failure describes the required ordering if the load operation takes place while for the load operation. So here we can either get what is the value? Well, like here's the new value and we succeeded, or here's the new value and we failed. And the two of these are going to use different orderings. I think we can assume that this will... we don't really care about the value on failure. We're just going to retry until it succeeds. So we'll do this in a loop. And we'll make sure, let's read our ordering requirements. So relax, no ordering constraints. Definitely not what we want. We definitely want ordering constraints. We want this to happen. We want to make sure that we are the only person who got this true. So when coupled with a store, all previous operations become ordered before any load of this value with acquire is stronger. In particular, all previous writes become visible to all threads that perform an acquire load of this value. Note that when coupled with a load, in particular, all subsequent loads, what about when coupled with a store? Doesn't talk about that. Acrel has the effects of both acquire and release together. For loads, it uses acquire ordering. For stores, it uses the release ordering. Note that in the case of compare and swap, it is possible that the operation ends up not performing any store, and hence it has just acquire ordering. However, Acrel will never perform relaxed accesses. Sexist. What does this mean? Like acquire release, with the additional guarantee that all threads see all sequentially consistent operations in the same order. I guess I just call this. I'm sure there's reasons that I wouldn't want to. It's probably slower. Okay, let's see if I can at least understand what's going on here. When coupled with a store, all previous operations become ordered before any load of this value with acquire stronger ordering. In particular, all previous writes become visible to all threads that are here a stronger load. So when I write this, anybody who's using acquire will see it. Okay. Note that using this ordering for an operation that combines load and stores leads to a relaxed load operation. I see. So that's the case that I'm in here, that I'm doing a compare and swap. I don't understand why. Memory ordering specify the way atomic average, blah, 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 and weakest only the memory directly touched by the operation synchronize a store load pair of ordering sequest. Sequence cyst. I don't know, man. Sorry. I'll just use that one for now, and I'll come back to it later. Okay. So we'll use ordering here. Sexist is the ordering. Yeah, okay, so we'll use the ordering sexist. I like it. And on failure, we don't really care, so we'll just use relaxed. And then we'll say, I guess we'll say, while this is not okay. Is error. And then here we'll assert that the loaded value is in fact what we wanted. Just to make sure that I'm understanding this correctly. And we'll use sexist loading again. And we'll assume that this is false. And then at the end here, we just need to make sure that we just need to return the thing. So spin lock guard. This takes in inner is self.inner, and available is self.available. Okay. And I think I just need to add some lifetimes here, like this. Linter doesn't like that I use assert EQ with false, so we'll just do this. And is this an actual compilation failure that I'm seeing there, or just a warning? Just a warning, so we'll move on. Okay, so now we've acquired a lock here, and then we can say impl drop for spinlock guard AT, which means our impl has to have AT. The drop takes self by reference, mutable reference. And here we just need to atomically, we need to like write true here. So I think that we can just say, we know, theoretically, we should be the only person using this. So we should be able to say that available, should just be able to use store unconditionally, write a true in here, and ordering, I guess theoretically it doesn't matter. Like, if I use relax here, I don't know if the following reads would work. With coupled with the store, all previous operations become ordered before any load. So I guess I could just use release here. I don't actually know. So I guess since I don't have confidence here, we'll just say do it like this. And in the future, we can come back and try to deal with this. Okay. Now we need to implement core ops deref and deref mute for the lock. Like this. So we make a new impl block that's very similar to this one, except instead of drop, it's deref. Our target is whatever t is, and I think this just takes in like a function deref, takes in self and returns t, I think. So in here, we can say that we just do self.inner this, and it's not mad at all. And I think I can just do the same thing for deref mute, which is deref mute probably, and mute, just drop a bunch of mutes everywhere, and this is actually a mutable reference inside. Can I not? So then I need some way for interior mutability, as they call it, which I think everything goes inside a cell, in unsafe cell, I think they call it. The core primitive for interior mutability in Rust. If you have a reference, then normally in Rust, the compiler performs optimizations based on the knowledge that it points to immutable data. Sure. Mutating this data is considered undefined behavior. Unsafe cell opts out of this immutability guarantee for and t. A shared reference and unsafe cell t may point to data that is being mutated. This is called interior mutability. All right. But how do I guess in the API here, since self is by reference, does it assume that inner is also by reference? If you create a safe reference with lifetime A, either NT or MUT, you must not access data in any way that contradicts the reference for remainder of that A. Yep, makes sense. So I can't mutate this while the spin lock exists. For ANT without unsafe cell and MUT, you must also not deallocate the data until the reference expires. As a special exception, given NT, any part of this that is inside an unsafe cell may be deallocated during the lifetime of the reference. Okay, sure. After the last time the reference is used, since you made, yeah, sure. At all times, you must avoid data races. If multiple threads have access to the same unsafe cell, then any writes must have a proper happens before relation and all, or use atomics. Right. Okay. That doesn't really... I don't know what that means. Can I... So, unsafe cell T, I think I can just say inner is an unsafe cell T. Which means that I have cell unsafe cell here. And we have atomic guarantees on like the acquisition of this thing. And so presumably I can just call get mute here. No, because that takes a mute self. I call get as mute T. Like this. So operation is unsafe. Yep. I don't really know. I think that this is correct because the mutability guarantees say that I'm the only mutable reference, and since we've like acquired our spin lock, then this should be the only mutable reference, and so it should be safe. Probably. Probably. That would be cool if this is all we need. And so now we just have to say like pub unsafe sync or unsafe impl sync for spinlock T. And so here our impl needs to say that it uses T, and I think that's it. Pub function, and I guess we need to make a pub function new, which takes in the T and returns a spin lock. Okay, we're almost there. So this means that we turn a spin lock with inner unsafe cell new inner, and available is atomic bool true. This starts as available. Okay. So as a quick sanity test, let's make a new type that is spin locked. So I'll say let locked equals spin lock new 1. We will use util spin lock, and print. So we'll say print line locked.lock and dereference it. And so here we should see 1 printed. It actually doesn't like that because this is a private type or something. So we just need to go like this. So we see 1, good. And now if I do this again, I should see 1 again. Good. And if I say let lock 1 equals locked lock, let lock 2 equals locked lock again, I should see this one finish first. So acquired lock 1. And this should say, uh-oh. We shouldn't see the uh-oh. Okay, so that's a really good sign. That means that like at least the basic logic here is working as expected. I should probably write some tests for this because this is like complex and will cause problems. But I won't for now. I might do it offline because I would have to implement like a lock with timeout to make the test work, and we don't have like this concept of time really like nailed down yet. So we have the RTC, but I would like to like really, I'd have to think about it a little bit more before I understand how that would all hook up together. So I think that we have like a way to lock the logger now. So we've implemented a lock, spin lock, and now we can use that spin lock to implement a circular buffer, an atomic circular buffer. So, and actually, in this atomic circular buffer, we could actually probably get away with, we could maybe get away with putting this stuff in a vector now. Oh, but we don't want to because we don't want non-atomic access. Okay. So our head will be an atomic usize. Use core. We need to now have atomic sync, atomic usize, and ordering. In here now, we have our array is a bunch of, let's make this a whole array spin locked. So this is using from migrate spin lock. Now, when we push now, we can actually, spin lock new. When we push an item now, I guess maybe we should spin lock the whole thing. I was going to say that we could spin lock only the items in the array and then increment the head and tail independently, but really like array, head, and tail are all really intertwined together. So these should actually all be spin locked the same. So let's do this. This goes into inner. And we have an inner like this, which takes in a T and an N, which means that here we need to pass in a T and a constant N of usize. Okay, so we have the pieces for our circular array. Now we just say that what we can actually do is we can actually implement a bunch of stuff on inner itself, which simplifies implementation, because then the outer, all we have to worry about is like handling locking, and on the inner one we can just use normal Rust code where we take in ourself as mutable, and it kind of just like separates the locking from the logic, which probably actually simplifies testing later, which is kind of nice. Okay, so here this is going to return self, and this is also going to be self. We are going to take in we're going to take in nothing, right? And array is now just not spin locked, it's maybe uninit. And this should say inner. And here, these are two usizes. Solid. Solid. I guess I should actually double check that the memory barriers created by atomics apply to the stuff in the arrays. Eventually we'll find, or I could not worry about it and wait till I find a bug. And that's more realistically what's going to happen here, is that I'm going to see some sort of corruption at some point, and I'll deal with it then. Okay. So here, circular array inner is inner new, like this. And push is let locked is self.inner lock. Because inner should be a spin lock inner T like this. And this should be spin lock new inner new. Like this. Okay, so now we have like a locked inside pointer. And on our lock we can just call locked push item. And then this will automatically unlock when we drop it. And we're chilling. So then when we push, what happens? So first we need a way to like get the index here. So when I say get the index, it's because like if head and tail are both 1, this should be like functionally equivalent to if head and tail are both 0. So let's think about this. We'll call this push back, actually. And what are our rules here? If head equals tail, it's empty. So that means head is where we insert. Tail is where we insert. I guess at all points, tail is one past the last index. So if our array size is n, so how do we indicate if it's full? So if we have every element full, head, that will look the same to us as if it's empty, I believe, unless we allow tail to go one past the end. So we'll add a function called like increment tail, probably. Is that what I want? We can increment the tail, then we'll know where to push to. So this will return like option usize for like where the new tail is. So then here we'll say insertion index equals self.tail. If we can increment the tail, if new tail equals self.increment tail, if we can increment the tail, then we're good. Otherwise, we bail. So we should actually be a match statement, self increment tail. And if this gives us some tail, self.tail equals tail. And if this gives us none, we have to return failure. So we'll return return error, push error or something. Push error doesn't exist right now, but we'll assume that it does. So here we'll say this is a result, and on success it doesn't return anything, but on failure it does return a push error. And then here we'll just make a pub struct push error, and we'll deal with the implementation later. Okay. Then this is unimplemented. And then we just say that array insertion index equals item. What doesn't it like here? Expected due to the type of expression. Cargo check. What doesn't it like? Method not found on spinlock guard. Oh, what? What? So this is spinlock guard inner. Cargo check. Maybe, oh, expected maybe on init. I see. So maybe on init, new item. On init, like this. Okay, so now it just doesn't like the fact that the lock isn't like dereferencing correctly. So if I do this, does it? What doesn't it like? No method main push for the struct in the current scope. Found method push not found for the struct. Right, but it's supposed to deref automatically. Am I crazy? Deref mute push. Am I crazy? Let's go back and look at this implementation here. So deref mute return self.inner. What am I missing? Self.inner.lock. So locked is a spinlock guard of inner, and let dereft is this. Deref mute not found. So do I need to use core ops deref mute? That's crazy. I do. Oh, I renamed it. I'm an idiot. So maybe I don't need to use this. Okay, and then here, I just need to return the same result. So this is going to be nothing on success and push error on failure. Nice. And we'll call this actually pushback. Aha. And then we'll have a pop front, which is, this is going to just return an option of T, right? Because either there's elements in there that we can pop off, or there's nothing. So we'll just do the same thing. There's no item here, and we'll return this. Okay. So function pop front, and this is going to return an option T. And so we'll do the same. We'll do the same thing. So if increment head. And if we get a new head, self.head is head. Otherwise, return none. Okay. And we'll call this index, and we need to take head, not tail. And then we can say that if we will take this item in the array, and we will assume in it but that takes it by value, which is correct. So we actually need, okay, so what we need to do is we need to have a new item that we're going to return. And this is a maybe uninit. We swap this in to the array. So we'll say ret is self.array index. And this is core mem, not stdmem. And then we can just return some ret assume init. We can assume that this is initialized because we've already pushed, we know that if these indexes are valid, then we've pushed into the array and we've put something in there. Yeah, so I think this is fine. And then unsafe for the assume init. Okay, so now we just have to manage the index manipulation. So this increment tail is going to say if self.tail equals okay, how do we say this? So if head equals tail, it's empty. If head or it's full. So this is where it gets complicated. So let's say we're at like head 0, tail n. Oh, I guess this is full. Yeah, that's full already. Okay. Because tail is where to insert. N+1. Sorry. So yeah. Wait, is that correct? Sorry, I'm thinking. So we have a circular buffer. We're going to draw it as a circle to make things easier for thinking about. We're going to say that this is like 10, right? And here we're kind of split into slices. One, two. And so if head is here, can we, and our convention is that tail is also here, that means it's empty. That means if tail is here, it has to mean it's full. Can we do something different where we say, so tail is where we want to insert, which means that we go insert here, bump it up. So we almost need to say, like, are we full as well? Right? Because if it's here, then we can insert. If it's here, we can insert here. We move all the way around, bump. And then tail would have to be here again, but it's wrapped all the way around. So in reality, we would need like an extra sentinel value over here that says we're full. And if we're pointing here, then we know that the tail is head -1. Which makes sense to me. So let's implement that. So first, let's add like a wrapping increment function. So here, we'll just put at the top, we'll say like function wrapping increment. And this is with takes in a usize and a container size of n. And then we say, no, this is wrong. So we can just do increment tail in here. So no, that is what I want. Sorry, I'm flip-flopping. So we'll have a wrapping increment, and we'll say that star I equals I plus 1% container size, like this. Like this. And we'll have a wrapping decrement. Which is, I think this has to be a little more intelligent. We say if I equals 0, star I equals container size, else I minus equals 1, right? Which in reality, we should test these. These are like really, really easily testable, but whatever. Then here we can say that wrapping increment mute self.tail n, right? And we can say if self.tail equals self.head, self.tail equals n plus 1. Right, so this is going to be our sentinel value. And we can also say if self.tail equals n plus 1 off rip, in that case, we cannot increment it. So we'll return none. Right? And now we also need to realize that we can't use this tail value directly like we were before. Because if it's at n+1, it needs to be a wrapping decrement from self.head. No. No, maybe this is fine. It might all work out. So now we return sum self-tail. I'm not positive that this is correct. There are some intricacies here, so here, but we'll try this for now and see where it ends up. Here we'll have an increment head, and I think this just uses the same logic except for the n+1. So we'll just say that wrapping increment self head. And so we actually probably don't need this function here. So if self.head equals self.tail, return none. And then wrapping increment self.head with the continuous size of n. And then I think we're good. So let's think about this. I guess we should write some tests. Otherwise, I won't be confident. Because I'm very unconfident right now, actually. And so we'll say use create testing star and use super star. And now we'll say create test. And we'll call this fill up buffer full. So we'll create a okay at first to say the test succeeds. And then otherwise we'll say, we'll make a new circular buffer. So we'll call this inner new. We can just call this circular array new. And this is going to be a circular array of I32s with size 3. Right? So buffer push back 1, 2, 3. And assert EQ buffer. I guess for each of these we should say assert EQ buffer.pushback1. Okay. And we don't want assert EQ, we want test EQ because assertions will crash my program. And here this okay needs some things inside it. And we'll do the same thing for 2 and 3. And this should return error push error like this. Cargo test. This won't compile because push error is not formatable or comparable, so we'll just assert that it is an error. So we'll say test true is error. Cargo test. Still isn't like that because push error cannot be formatted. Oh, okay, fine. Derive debug. And it also needs EQ and partial EQ for the testing to work. And cannot infer type E. Oh, that's so stupid. How can you not infer the type? Right? It's okay, whatever. Push error. I'm surprised that it can't infer that. So I guess we'll just use is okay here. instead. And then we can remove some of that stuff. Need some semicolons. Okay. So we can remove all this. So that's kind of surprising. I kind of expected that to not work. Let's create a new test to test popping. Pop empty, we'll say. And we'll do the same thing here where we test true, pop front is none. That also worked surprisingly well. Then we'll say push pop. Push pop pop, I guess we'll say. So we'll push a 1. We'll pop front. And is okay. We want to make sure that this is okay 1. Or not okay, sum 1. Sum 1. Somebody once told me. Okay. That works, surprisingly. So maybe this just works. Yeah, that's pleasantly surprising. So, synchronized circular buffer. Looking chill. Surprisingly. Okay. So now, all of that. We implemented a spin lock. We implemented a circular buffer. Why the fuck did we do any of this again? It's because we want to add a log manager that we can push stuff to. And actually, we wanted to build a channel on top of this circular array. But maybe we just won't do that for now. We'll just use the circular array directly here. So here we want to use create util circular array. And we'll make a log buffer here. So static log buffer is a circular array of strings. And we'll just make it like really big. Fuck. Okay, so why am I angry? Strings require heap allocation. I wanted to support non-heap allocated strings. Which is fine. We could make these copy on write strings later. Right, we could make this cow stir. Which means that here we need string. Where's borrow cow here? And this is a circular array new. Okay, and we also still need alloc string type for everything else. String. Okay, so cannot call non-const function. Shut the fuck up. Can I just write const here? Pub const function. Does this work? Spinlock.new. This can also probably be const. Nice. And inner can also be const. Cargo check. Make sure it doesn't like uninit array is not yet stables of const function. Let's just include this feature. Const maybe uninit array. It's fucking solid, man. Okay. Great. Cargo check. Okay, cargo run. Okay, so we can compile again. Now we go back through all of this. So we have this log buffer now that's static. We now have a service function on the logger. And in the service function, we while let sum v equals log buffer dot lock dot pop. We gotta pop it and lock it. Oh, it's such a bad joke. I'm sorry. I'm sorry. Please forgive me. Oh, we don't need to lock because it's handled inside. Print line v, right? I think that's it. Trailing semicolon. And then I think we're chilling. So now in main, we can call service on the logger. And here, we'll just say, we also need a static logger here as well. Which is a logger. Which I guess we now just also hide behind a spin lock. Now that we have a locking primitive. And this is spin lock new logger new. Which means that this does in fact need a pub function in it, which initializes the static logger. So this just is a private function. This now we do something like this. And this comes in here. And this is like this, patch map new on the new function. Here we need to use create util atomic circular array. What is this? This is in util. We also have spinlock, I guess. And I guess in reality, this like atomic circular array probably shouldn't exist. It should just be like a circular array that we can put behind the spinlock type, and so we'll adjust that later. But I don't want to handle that right now. What doesn't it like? Remove the whole use unnecessarily curly braces. Sure. So this should be like this, and this should be like this. Okay. So we'll fix that later. So I have a spinlock logger in here. We can call. We actually don't want to do that. We don't want the logger to be spinlock because then somebody could hold the lock while we're in the interrupt. We actually want the logger to put its levels in a spinlock. And probably we want the buffer owned here as well. So really we just want to go like this. And here we have the items, or like logs. We need to put static in here so it doesn't get angry. And we have to just be very, very, very careful about how we handle the locks here to avoid locking up our interrupt mid-log. So I think this actually works out. So the levels, we only ever do a very quick lock on them to get the log levels. And in our service functions, we call self.logs.popFront. And this will lock to get the most recent log. And after that, it will unlock. But we could actually end up interrupting in here, which is fucking annoying. Oh! Ugh, it's so annoying. So I guess in reality, a lock isn't good enough. You almost want like an interrupt lock that makes it so that we can't preempt during this. Oi, oi, oi. I wish I'd thought about this before right now. So really, this whole spin lock is just like fucking useless. Or we can fail to lock it. Let me think. I'm thinking. So we are running in a single thread. We need to avoid interrupts while we are doing some things because we expect to be using them from the interrupt handler. Is there another option here? We could drop logs, but if we drop logs, then there will be just like zero indication that an interrupt ran, which is just like fucked. We don't want that. So in reality, we want something more like an interrupt safe or interrupt disabled guard. And maybe you would actually still want a spin lock. That's okay. So we're basically saying like while we run some code, do not interrupt me. Which seems maybe sketchy in some way. I don't know how like buffered interrupts work. But it does seem necessary. And really, we might not need the spin lock at all in that case. Because right now the only thing that can preempt us is an interrupt. That is reasonable. So really I should just delete this spinlock class I just wrote and replace it with interrupt guards. Okay. I can buy that unused. And we'll call this implement interrupt guard. I wish I had thought of this earlier. Okay. So the question is, do I want to like keep this spinlock implementation around? It seems like not useless. So I probably will keep it. And we'll go back to interrupt. We'll make a new thing, interrupt guard. And it'll actually look very similar to the spinlock. So I'll just literally copy paste the whole thing and %s spin lock interrupt. We on drop will enable interrupts. But we only want to do that if all interrupt guards have been deleted. So basically what we want to do is when we acquire our item, we want to call disable interrupts. And when all possible things in the world are ready for interrupts to be re-enabled, then we re-enable it. So we actually need a like count of how many people in the world of our kernel are expecting interrupts, which means that we just need a static variable, which is num disabled num guards. And this is an atomic U size. which is going to start at 0. On drop, we try to just decrement this. So is there like an atomic decrement on usize? Or do I just have to write it around compare exchange? Load, store, compare exchange, fetch, add, fetch, sub. Here we go. So subtract from the current value, returning the previous one. This operation wraps around an overflow. Fetch sub takes an ordering requirement, which describes the ordering of this operation. All ordering modes are possible. Okay. Note that using acquire in the store makes this operation relaxed, and using release makes the load part relaxed. Ah, that makes way more sense. Okay. So I want the sexist ordering, SEQCST. And I think that's, then I want to make sure that the thing I get back is 0. And only one of the many guards will get 0 here. So we'll say self num guards fetch sub. And we want ordering sexist. And this will, so it takes an order, subtracts from the current value, returning the previous value. Returning the previous value, which means that if this is, if here we subtract, yeah. Okay. So here we want to say if is that what I want? Because here it's going to return the previous value, but if the previous value was 2, okay, yeah. So I think I'd say fetch sub 1, and if the previous value was 1, then I can assume that it's time to release. So unsafe ASM STI, right? And these deref guards are going to be the same. Here we're going to replace interrupt T with interrupt guarded. So interrupt guarded. Oh, but it doesn't like that. So I need to like escape this or something. Interrupt T. Why doesn't it like that? Oh, whatever. We'll do it by hand. Interrupt guarded. Interrupt. So here, this is interrupt guarded, interrupt guarded, interrupt guarded. Then that's a guard. Okay, so now we're in the same boat here, where here we can just unconditionally increment this. So we say num guards, fetch add, or 1 with strict ordering. Oh, I guess it doesn't matter. Well, I was going to say we can put relaxed, except for the fact that we need it to be ordered on the other side. Here we had 1. And then we call this. And I think we're chilling. So we disable interrupts. Then we, yeah, I think that's it. So let's go to util and add the interrupt guard like this. And then we need to use core arch ASM like this. CST needs to be with capital. This needs to include atomic U size, or else it gets mad. And this doesn't have this field anymore. And this needs to be interrupt guarded. And this is not really technically sync, right? Because if I had multiple threads, then this won't work. So I'll just say that note, unsafe sync implementation assumes single threaded OS. Sup, Yosh? Okay, so we've implemented an interrupt guard. We actually don't know if this works, but we're just gonna assume it does for now. The best kind of testing. Okay, so now we have an interrupt guard, and that means that now our logger, we can put this stuff in interrupt guards. And that means that they won't be able to preempt themselves. So again, we just need to do a couple renaming here. So this is not atomic circular array anymore. This is just circular array. We go into the circular array implementation. We need to rename that file from atomic circular array to just circular array. And then let's take out the spinlock shit from in there. So in circular array, basically anything related to spin locking in here, we just remove. So this inner can just be circular array. And here, this outer thing, we just say, fuck off. We don't need you. And then we need to publicize these functions for use externally. And I think that's enough. So what doesn't this like? Right, there's a lot wrong now. So in our logger, cannot find type interrupt guarded. So we'll replace this with interrupt guard, interrupt guarded. This is now no longer an atomic circular array, just a normal circular array. It's a private struct, so we have to go fix that. Oi, 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 so much code shuffling. And so now we also need this circular array to be interrupt guarded. So when we access the circular array and we access the levels, each of these individually will disable and re-enable interrupts. Theoretically, this could cause problems if I have other critical sections that are manually managing interrupts. Because I might just like re-enable them halfway through, but we just won't do that. Easy fix. Okay. So this disables interrupts, gets the log, re-enables them, returns it, gets level. And this is just the same thing where we lock to disable interrupts, get the guard, and then we pop the front, and we re-enable interrupts again. So they should only ever be disabled for a very short amount of time. And this now just needs a quick little, we need to initialize these appropriately. So this needs a comma here. New is private, so we need to go fix that. This is public now. And it should be const pub, not pub const, or pub const, not const pub. And I think we're chilling. So now here I just call logger init instead of logger new. Like this. And this takes in the default log levels. So log levels hash map of logger of string, which is module name, to log level. And do we compile? That'd be sick. Close. Very, very close. Non-const function new. Okay. Cannot call non-const function hash map. Oh my god. Oh my god. Okay, we can dodge this by making this an optional. And then we say expect here logger not initialized. And then it's trying to return temporary value, so we will just fix that. We won't return the level by reference anymore. We'll just copy it out. So we'll derive, copy, and clone. And we'll dereference what we got from the map. So we take this reference, we turn it into a new thing we copied out. Cannot move out of dereference. What is it fucking complaining about now? Cargo check. Help, calling as ref or as mute to borrow the type's contents. The move occurs here because the type option map, which does not implement the copy trait. Sure, that's fine. What am I missing? Let level is this. Oh. As mute. As ref, I guess. Jesus, look at that absolute shit show of a line of code. What a disaster. That's okay. Okay, so finally, we're at the point now where we have a logger in static memory. It should be safe to use from within the context of an interrupt. And now all we need to do is use the log levels to guard whether or not we want to run this print. And instead of printing here, we're going to push to this guy. Circular array, copy. Yeah, okay. I think all that works. So we can say logger get level module name, I think was what it was called. Path. If logger get level is greater than or equal to the level that we requested, we can add a function here to push a log, push log, which is a log, which is a copy on write static string. We say log self logs push log. Cool. Push back log, maybe. No method names. All right, so we need to lock this. Disable interrupts. And here, we just need to make these partial, ord, partial, EQ, and EQ. Just to say that, like, this is a comparable thing. Okay. And so if we are above the current log level, instead of printing here, we will call logger push log. And we will format this as the format string and the arguments with this like fucked up macro syntax. Which is alloc format, I think. And I guess, fuck. Okay. So we'll have two versions of this. One that will construct a dynamic string that is pushed into the logger, and one that takes a static string. So this macro expansion should match I hope will match only when there are 3 or more arguments. This should match when there are 2, which means that here I can say just do s into, and here I can do format into. And these need semicolons after, And the format needs to be alloc from the allocation crate because it will allocate a string. Okay, so first we should pass in a static string. And I wonder if we can here we should print line failed to push back to dropped log. We don't actually want to print that there though because it's expensive, but maybe printing only on the case where we fail is pretty reasonable. So we'll say if we fail to push a log back, we'll do this expensive print with interrupts disabled, but hopefully that doesn't happen very often. And if it does, it'll like fuck up our system. So maybe we should say panic actually. We'll say like, fuck this. We ran out of space, and the only reasonable response to not being able to log a debug log is to just like fucking explode the system, crash the kernel, who cares? Yeah, obviously there's a better approach to this, but in my world right now, this just means I have to increase the size of the buffer. And I also want to, for now, temporarily, confirm that I'm getting the static version when I can and the dynamic version when I can as well. So let's see. Logger not initialized. God, you're such a whiner. Fine, I'll initialize it. So we'll say logger levels equals some this is usually logger lock dot levels is some log levels. Just pass in what was given to me by main. Some of the expression fields have method names levels and logs dot. What are you talking about? Oh, levels dot lock, not lock dot levels. Aha. Okay. So I printed. This is surprising. Why is this printing test and test one? Oh, I want to print if these. Oh my god, are you serious? I can't print like. I want to know which type this is. Does this guy have like a is borrowed function? Nope. I guess we'll just print it. Match log borrowed b. This will say print line borrowed, and the other one will just print nothing. So all we want to know here is that this like copy on write type. Oops, trailing semicolon expression. What are you bitching about? What are you bitching about? Cargo run. Macro expansion. You might be missing a semicolon here. Okay. I don't really understand why it doesn't like that. But I'll take it. Okay, so it is correctly saying that if I call my logger like this, it will not allocate any strings, which is really good. That means we can call this version of the logger before we've allocated anything. And if we call this version, then we're going to do a dynamic allocation, but that's okay. So I do think that now if I put logs in the allocator, that will all work correctly as long as when the manager comes up, then I service it. So now I just have to call service in a loop somewhere at the end. So in reality, in the future, this will be in a loop. What I can do for now is just call it once. Logger, we'll call this service, I guess. So we'll say pug function service, and this will print all logs that have been delayed. So we'll say, how do I call this? Self logger service. And we'll take out these print lines here. And now what we see is nothing happened because, how do I say this? Nothing happened for a couple reasons. One, because we're returning early, but also because we're logging in debug, and debug shouldn't, right. Ooh. That's fun. So this logger initialization actually has to come after GDT initialization because the GDT expects interrupts to be disabled and this guy re-enables them. That's a good thing that I put that assertion in there the other day. Now we're fucking crashing. Oh, because interrupts can't be enabled right now. Fuck. Okay, hold on. We can fix this. Git commit -m temp. And because I need to fix my interrupt implementation before implementing this interrupt guard. So here we have an interrupt implementation. I can just say, we'll check out the interrupt implementation. Rebase this onto master. Merge anything that is broken. So here we just want both things that we added. And is there another thing here? Here we just want both things. And let's just finish this rebase and cargo run. Let's go! That's sick. Woo! All right. So this, okay. This isn't very explained. What we have right now is we have a global logger that is now logging things if it's like pushing logs to the back of this buffer, and in a way that should be safe from the context of an interrupt, where we've had like a nice little macro to execute those logs, and we're seeing them printed later after our first call to service. So all of that means that I think that this is mostly ready. The only problem is that we might need to split out some interrupt guarding stuff to make sure that like we know GDT initialization and interrupt initialization probably should use the same guards that we're using for interrupt handling in general. All right, so that's sick. So what's next? What is next? I guess now let's prove that we can log from an interrupt now. So let's see. We have these like random. We just have like this one interrupt handler right now, and all it does is call printline hi. But in reality, we want him to log at debug, or maybe info for now, and we'll say that we are in fault handler. And I did some implementation. I cleaned some of this off screen, which is annoying. I wish I had that code here, but that's okay. So I've got an interrupt handler that will handle interrupt 13, 14, 15, 16 right now. We'll ignore the fact that we're using this same handler and that the name isn't right, etc., etc. For now, we'll just say that we have this. Let's include the info log, and could not find log in the crate root. Logger info, I guess it's called. And it's called log here. And I guess I probably need to macro use that. So here, I actually don't need to import this. So in here, if I just say logger log level, I'm now logging at info, and we can't find the loggers. So this needs to say that we're in crate logger everywhere. Static logger is not available, so we do unfortunately have to make this public for this to work. And we need to use $crate instead of no $crate, and this macro export isn't working. Okay. So now what we want to see is if I trigger that interrupt, so I just say like ASM int 13, I think it's like this. I want to see now that that interrupt is triggering a log message that gets printed later. And look at that. Look at that. So I execute interrupt 13 after initializing the interrupt handler. In here, we have our fault handler, and he logs at log level info, and he says he's in the fault handler. So that's sick. That's really sick. I'm pretty happy with that for now. There's a little more work to be done here, but I think that we've kind of done enough to get the initial infrastructure up, and everything else is just kind of like cherry, like a little bit of like sugar on top. So I'm pretty happy with that. We'll probably go back on tomorrow and try to finish up some of this like interrupt stuff. So right now we just have like one interrupt handler for ASM for interrupt 13, and probably we were going to try to build out some sort of like interrupt handling registration mechanism so that drivers can register interrupt handlers, and we also need to like enable the interrupts of like external devices, etc. So that's probably what we'll do tomorrow. If you want to catch it live, I'll be on, sometime around 2 PST, and if you want to catch up later, you can always catch the videos on YouTube, which is linked in the Twitch description. Yeah, thanks for watching. Catch you on the next one. Bye!